1, 2, 3. All right. Hello, everybody. Playwright can do this, and I want to kick things off with a little bit of a history lesson. Who knows this logo? Well, good old Selenium, right? I used that 10 years ago. I'm showing my age a little bit here. Let's continue the front-end journey here. What about this buddy? What? Okay, this is 10, 15-ish people. So this is the logo of Frontend.js, which, when it came around, was one of the first tools that came with the JavaScript API to control a headless browser, right? And everybody, I myself included, I built a lot of tools with Frontend.js and it was quite cool. So it had some downsides though. It was controlling headless WebKit. And then we had this buddy here, which was an abstraction layer on top of Frontend.js. You see we had a thing for ghosts going on for a while. So this was Casper.js and one level on top of Frontend.js. And as you see, I tested a little bit with the technologies that are out there. I'm Stefan, I'm from Berlin. I blog a lot, I love technology, and I work for a company that is called Checkly. And we provide API and end-to-end monitoring, which leads me to play around with Playwright quite a little bit. So let's get into this. And shameless plug, I write and send a weekly newsletter. So if you're interested in front-end news and all the good stuff, not necessarily framework specific, you can check that one out. And since the beginning, I'm pretty much convinced that end-to-end testing is a good idea, right? If you have 1,000 unit tests and all your components, API endpoints, or whatever you write has 100% test coverage, it doesn't really matter if these components are failing working together, right? With end-to-end testing, with a headless browser, you're testing your database, you're testing your APIs, you're testing your front end, all in the same stack. But let me tell you, it was terrible. Super, super hard to do. Because tests in my experience were slow, hard to write, and flaky. And the problem here is really when you invest a lot of sprints and a lot of time and a lot of effort to come up with an end-to-end testing solution, and you end up with a test suite that runs 30 minutes and fails every second time, well, then you're kind of missing the point. And I've been there with colleagues, and at some point you decide then, hey, it's too hard to run this thing, right? I just want to deploy a hotfix right now, but I have to wait 30 minutes for the end-to-end tests to wait, and then I have to run it a second time because the first time didn't work. If you decide to run your tests on demand, it's similar to saying, okay, I'm giving up on end-to-end testing. We've been there, we've done that. Guess what? The end-to-end testing suite was outdated rather quickly, and all the effort that we put into these kind of things was just for nothing. But things, so starting with the ghosts and Selenium, things got a lot better over the time. So Puppeteer by Google is a framework that you can use to control Chrome. And then now Cypress is the coolest kid in town now for a little bit, which, was that a clapping for Cypress? Nice, so someone is clapping in the back for Cypress. So it's around for, I don't know, it's the main thing, 3-4 years now. Pretty decent, pretty good stuff. But I think that the JavaScript community is not talking, sorry for you in the back, is not talking enough about Playwright. Because Playwright is actually pretty decent. And when you think about Playwright, Playwright is pretty much done by the same people that initially wrote Puppeteer, but they just changed companies, went to Microsoft from Google, and rebuilt the things from scratch and avoided all the architectural mistakes that they did the first time. So first of all, a few key facts about Playwright. Playwright is across everything. With Playwright you can control Chromiums, so Chrome and Edge, you can control WebKit, and you can control Gecko. It works on all operating systems, so macOS, Windows, and Linux. And we're in a JavaScript event here, so it works with JavaScript, TypeScript, .NET, Python, or Java, if that's what you want to do. And it is comparing it to Puppeteer is more than just a browser control. Playwright these days comes with a full-fledged and mature test runner. So you have the usual test describe, test before each, test, wait, expect, all these kind of things that you want to do when you write a lot of tests, which you really want to do because you want to make sure that your products and sites work. It is all baked in. And it is easy to parallelize so that you can save a lot of time while running your end-to-end tests. So if you want to run and spawn different processes running in parallel and performing all your tests, this is just a single CLI argument or a line in your Playwright config, so that you can run things in parallel and maybe cut your testing time in a quarter. And it is built for quick execution. So the team behind Playwright really wants to make sure that you're not spending time writing random wait for statements. So if you do end-to-end testing, usually it's just one thing or a few things. You load a website, you wait for something to show up, right, a button, then you click it, and you wait for something else to show up. This is all that usually comes to end-to-end testing. In Playwright, this is all built in using two things called auto-waiting and web-first assertions, so that you rarely have to write wait-for statements. And I will show you how that works in just a moment. Yeah, shall we do it? All right. What I'm going to do, are we mirroring here right now? Yeah, we are. Okay. So what I have here is my little VS Code window, and I have my, is that coming good, okay, to the people in the back? Okay. So I have my terminal here on the right side, and it is fairly narrow, but I just use it to run some commands. And I have here a meet.js spec file. So what I want to show you first is that Playwright comes with a code generation tool. So if you want to get started, what you can do is you can call this one command, and it opens up the Playwright inspector. And now you have a browser showing up, and when you click around, you see here the Playwright is recording all the actions that I'm doing. So if you're new to end-to-end testing and you want to figure out what is happening, you can just spin up a single command and it will then write your Playwright script for you, which is actually pretty cool. But you have to be certain that when you use these kind of tools, the selectors are usually not that great. So this is kind of like a getting started point for your end-to-end testing journey. So when we now go on, what you can then usually will do is you will just write npx playwright test, which runs now all your end-to-end tests. And what you see here is that I have defined 5 tests, but it is showing 15. And the reason for that is that is currently running with Chromium, WebKit, and Firefox. So what we can do is we can also run it in headed mode. So you see now different browser windows showing up, and this is me cross-browsing testing the meet.js website, which I didn't show yet. So let's open this one up. So this is the site that we're running against. This is on my local host 8080. It's pretty much just the meet.js site running on my local machine, except that it has a little confetti button, which we will also test a little bit later. So when we now go on, what you then also can do is, which we will need later on, you can also run everything in a debug mode. npm playwright test debug. Which is kind of cool when you want to run your tests and you're controlling a headless browser, right? You want to show or want to see what is actually happening. So when you go on here, you can then just go step by step through your tests. Right now, all my tests are a little bit empty, so that is a little bit boring. But if you have problems with your test cases, you can just spin that up and you can start debugging your functionality. And I think this is just super, super handy. So when we now go back, we can actually get started and fill all these tests with live. The code base that is powering this thing here is pretty much just the boilerplate that comes with Playwright init. It comes with all the structures that you need. You can just run it and you're ready to go. And I will go to the Playwright config now. And first of all, I will disable 2 browsers to save some time here. And there's one file that I added, which is this one here, which is my kind of cheat sheet when I mess up. All right, so let's get started with the first thing. If you write a test in Playwright, you can just add a test function. What you then can do is you can go in here. And let's just start by testing the page and that it has the correct title. To have title, do it like this, add it like this, and that it is. And then let's just fetch the headline and do page locator, h1, and now do await, expect, headline, to have content, to have text. And let's do the same thing here, meet.js. So if we now run this, congratulations, we just ran our first end-to-end test, and it seems to be working. When we now break this, we can see that it's really working. So when we change the thing here, this will now take a moment until it fails, but this is all it takes to get started and rolling with your first end-to-end test with a headless browser. So this is now failing, so just so that you have seen it, here are our test cases. You can also have different reporters to kind of show you, hey, what is the output? You can make it machine readable, or in this case, you can have an HTML reporter, which now tells us, hey, we have an issue here. Cool, so let's go on, let's make our test work again, and let's continue by testing if these little toggle things on the website actually work correctly. So what we can do is here, what I want to test is these things here. Right, you can click them, and they are opening and closing. And to test these kind of things, what we can do is we can go in here, and I will just add a snippet, because you don't want to see me all that typing. So what we're doing here is we're selecting one of these boxes that include a certain agenda item, and then we're selecting the headline, and then the bottom, then the body of it. So what we want to do is we want to test, first of all, if the agenda item body is hidden initially, like this, and then we want to click the agenda item headline, and then we want this body here to be visible, right? To be visible. Cool. So this is all it takes to write this test now, and when we now run this, this should pass. But the thing with headless browser testing is always like, it's headless, right? Did that really work? Of course, we could now always break the test and figure out if that's really true. But if you're doing end-to-end testing with headless browsers, what you always want, or what you always will end up doing, is you're screenshotting the hell out of all the things. So what we can do is, we can also add now some screenshots here. And let's call it "We're live." Oh, there's a typo. "We're live and scared." Let's say "I'm live and scared." Huh? I'm live and scared, and give it a file path here. So we can now run this thing, and this will now immediately screenshot the website at this certain stage, right? So when we now go to this screenshot directory, you will see here that there's a new screenshot, which is "I am live and scared," and here's indeed the website at this moment in time after this test suite. So, but what I think is also cool is that you can now go on, and it's not only page screenshots that you can also do component screenshots. So if we now want to grab this particular item here, we can also screenshot this tiny thing, so item here. Let's run this test again. When we now look at the screenshots that were generated, we see here now that this is now a screenshot of this particular component that we just screenshotted. So if you're kind of doing image comparison or these kind of things, this can become super, super handy in case you don't want to select or screenshot the entire component. But as a next step, what do we want to do is, maybe you want to also include something that is something like visual regression testing, right? You want to have a base, and then you want to screenshot something, and you want to check if your CSS is messing up things. So what you also can do is you can do await expect, and then you can give it the item, and then you can say to have screenshot. Which is kind of cool, screenshot PNG, because visual regression testing is included in Playwright itself too. So I think this is super, super fancy. So this now failed because we are running it for the first time. So we have to, first of all, update all the snapshots. So let's generate a snapshot file. And when we now go to this snapshot file, which is now, what did I call it? Screenshot. So here we now have our base snapshot file. If we now start messing around with this file, I'm sorry, Christoph, I'm drawing over your face here. Are you in the audience? Yeah. So when we now change the base file here and rerun our test again, you will see now that we just implemented visual regression testing with a few lines of code in Playwright. And I think that's pretty nice. So we now have here a div that comes out of test results. Here we go. So here we have the screenshot that was taken. Here's what we expected. And here we have an image div if you are fancy and want to see actually what changed. I think this is pretty, pretty nice. So let's just update the snapshot again to move on. So let's go back to a file. How am I on time? OK, I'm pretty good. So let's continue with this kind of confetti story. And I think it's not really clear yet where this web-first assertions and this auto-weighting comes in. When we go to this website, to the meet.js site, and you refresh this, you will see that the celebrate button is only showing up later. right? So you have to wait for this button to be around to actually click it. This is actually built into Playwright itself. So let's go into this test case here, and I'm selecting two things here. So I'm selecting the party time button, and I'm selecting a random canvas element, because the confetti is just implemented in the page with a canvas element. And note here that page locators are not async, you don't have to await them. These only hold the logic that it takes to query an element in the DOM. So what we now can do is, we can start writing our assertions with await expect canvas to have count. So we want, first of all, we don't want to have a canvas element. Then we want to have the button to be clicked. And remember, this button is not there initially, but Playwright will automatically wait for this button to appear. And then we want to have one canvas element, and then we want this canvas element to disappear again. Playwright has all these waiting mechanisms built in and will time out if it takes too long. But this means that you don't have to write a lot of wait for this button, wait for this, wait for this. This is all built into the framework, and I think this is one of the big strengths of Playwright itself, to really write fast and not flaky tests. So if we now run this test suite, you will see that it takes a little bit longer, because this is a slow test, because we have to wait for these kind of things to appear and disappear, but it seems to work. How can we check that that actually really works? You might have noticed here in my VS Code, there are these little triangles. So Playwright also comes with a little VS Code extension. So if you prefer to run your test cases not from the terminal, but from within VS Code, you can do this too. And also, if you don't want to use the debugger tools that I already showed you, you can also just spin up the Playwright debugger right here, and then you can step through your stuff right from within VS Code, if that is your thing. I prefer running things from the command line. Okay, 2 more things to go. Let's check that this website is actually high quality. What you can always do with end-to-end testing and with Playwright or Puppet is you can always mess around with the network. So what I want to check here very quickly is just that this page doesn't include any 404 pages. And you see here that you can always listen for requests, responses, for console messages. If you want to measure the quality or what is happening in a website, you can always do this and just kind of start fiddling around with the page that is loaded. So what I want to do is I just want to check that the status code is not greater than 400. And if it is, I want to push a URL to a, push a URL to an array which does not exist yet. So let's do const not found equals array. This looks good. Now the thing is that this test right now has the website already loaded in the before all block, which is here on top. Right here we have the before each. So we now have to just quickly reload the page so that we can catch these events. Now we can do expect not found length to be 0. To be 0. Sweet. So now let's run this test. Surprise, surprise, I think that this test will now fail because I intentionally brought in a not found resource here. So when we look at the network waterfall, you see that there's an image that is called not found and a few others. So this is intended to fail. So let's just skip this one because I don't want to run these tests again. And we're coming to the latest test that I just want to show you. It's LCP. So every end-to-end testing framework usually gives you a set of functionalities, right? If you want to evaluate and do different things, what you can always do is you can come in with a page evaluate block and do kind of inject some custom JavaScript in the website that you're fiddling around with if you want to do custom things. So what you see here is that I'm creating a new performance observer to get the largest contentful paint metric. And when we now check against this one, and I'm doing very poor number parsing here, don't judge me. So let's that be smaller than 200 milliseconds. If we now run this end-to-end test, we have a green test suite. Let's just see if this one is working. 30 milliseconds, largest contentful paint. We're running on a local server here, but this seems to work, so this is all good to go. So, but there's one question that remains. What happens now when you run your headless or your browser tests on your local machine? That will probably be debuggable, right? But what happens when you put it in your CI system or to your colleague's machine or to an environment that you don't control? How do you do these kind of things? And Playwright comes with something that is called tracing. And this is honestly pretty cool. So I'm here in my Playwright config, and it is enabled to trace on a first retry. So let's just enable retries here. So a retry just runs the test again when something fails, right? And when we now have here a 1, which tells Playwright to run a task after it's failing, you see now that there's this 5 that goes to 6. So tried to do one test, and what now happened is, because this test still failed, Playwright now generated something that is called a trace archive, a trace zip file. And this zip file basically includes all the information of what happened in this test case. So what we can now do is we can grab this little command here, we can run this one, and here you pretty much see all the information of what happened in your test case. You have some screenshots, you have all the actions, you can see what happened in the network waterfall. And this is kind of perfect for running your stuff in CI and then downloading it and inspecting it. So you can run this on your terminal, or you can use an online viewer that Playwright provides. Whew. All right, I'm a little behind schedule. This is the little live coding session here. So I showed you how auto-wait and web-first assertions work, how screenshots work, test runner, the retries, tracing, VS Code extension. I think it's just a super nice, complete package. And I'm pretty much amazed of the functionality that Playwright provides. Just to give you some good practices on the way, I wrote terrible selectors. So you shouldn't do this. So selectors should be unique, stable, and concise. So you usually want to rely on IDs or data attributes. They should be stable and not change. And they should be as short as possible, because nobody likes to write all these long selectors, right? And your test cases should be short and idempotent. It's a very terrible word to say. So I, in the past, wrote end-to-end tests that started kind of logging in, doing this, changing this, doing this, doing this, doing this. When you write these end-to-end tests, you cannot parallelize them. And you have the problem, if your test case fails at the end, you're starting from scratch again. So what you want to do, actually, you want to keep your end-to-end tests as short as possible so that you can run them in parallel to kind of shorten the time of your test cases. And then they should be idempotent, right? They shouldn't leave any traces, and they should work in any case, right? Think about a database, and you're always running create account, create account, create account. At some point, these scripts won't work anymore because you're just cluttering your database. And there are a lot of cases where scripts are not idempotent. And this should work in any scenario. It doesn't matter if it's successful or if it's failing. Actually, what we do is we pair API calls with end-to-end tests. So we do raw level API setup and teardown scripts to make sure that we're not cluttering our database. And the end-to-end test has the status of the system that it needs to perform the UI tests. So I really want to say that we should start treating our UIs like we do our APIs, right? When we think about APIs, we talk always about the 4 nines, 5 nines, 6 nines. But funnily enough, we don't do this with our UIs. And somehow it is acceptable that we treat APIs with 5 nines that serious, but have UIs where every now there is a layout glitch, right? Or something is not working here, or something is not working there. And I see that way too often. And I think we should take more care of that. And we'd already earlier heard about Rachel and Brian Ketlover. The front end drives at the end the revenue, right? If we test things, we should start at the beginning and test the entire system. So your entire application should be tested at all times. And I would really love to see us looking more at systems which is like 20 seconds. That we look at kind of monitoring dashboards that is like, hey, this account logging worked that many times and has an availability and functionality uptime of 99%. And I would love to see this. I was rushing a little bit. Whatever you do, the tech doesn't really matter, but start end-to-end testing your applications. Because I think we kind of own it to our users that we ship good stuff, and that they are not the people that are telling us that something is broken. End-to-end testing should be your safety net, and yourself in the future. And now it's time for lunch. If stickers are your jam, I will place a bunch of stickers here, so if you want to catch these, I will place them there. And with this, I'm Stefan. Thank you very much, and have a good lunchtime.
Hey, great stuff. Right on time, by the way. Okay, one question. I know everybody wants to go to lunch, but wait a second. We have one question, but before the question, so that people know what's happening. There's lunch. You can go there for the lunch. But if you prefer to get some more exercise instead of standing in a long queue, you can stay here for a bit, have some exercise. We're going to have another round of exercises, and join the queue later. We have enough lunch for everybody, as far as I know. Didn't eat it all yet.
I hope.
Yeah, so now that you know that, I have one question that you didn't yet address. Can Playwright handle auth and social logins like Facebook sign up? It has pop-ups and everything. Would it work?
Pop-ups work. Social logins are not a Playwright specific topic, right? You have the problem with the same things. For social logins, yeah, well, you have to kind of figure out how to test the email that is sent, or if you want to create accounts, right? You can work around. Technically, it works. It's always a little bit of a hassle. 2FA works too. Depends a little bit on the provider.
Okay, works. And one more question that's awfully important. What font are you using in your editor?
The font is Fira Code iScript. And if you're curious, I also have this terminal thing going. Let me just show you my terminal where I have random emojis on every line. And it sparks joy every day because sometimes I get the middle finger. So if you want to get this one, catch me later. I will tell you how this is done.
Okay, thanks. One more clap.